Hi guys, welcome back. It's Professor Hank, and in this video I'm going to talk to you about the Singleton design pattern. So let's go ahead and get started. So the Singleton pattern is an approach to designing a class that you use when you want to guarantee that you have a single instance of that class at all times. So one reason why you might want to use this is you're putting it in charge of some data store. Say you have one vector and you want that vector to be the central repository to a bunch of integers, right? And that should be the one location where it's stored. You don't want to have any duplicates, any duplicate vectors at all. It's going to be just that one. So you could put that vector in a Singleton class that guarantees that only one instance of the object that has that one vector will ever be created. Maybe it's in charge of managing a database and you don't want to have 2, 3, 4, 5, 6, 7 instances of the class that is controlling the database. You want to have one person who's in charge. So a Singleton class is what you can use to make that happen. Another common example that you'll see is when you have, the government. There's all these different entities in a country, and they all go to one government. Not a bunch of governments, but one government. So the key to making this thing work is going to be to make the constructor be private, so that way the object can never be instantiated on its own. And you'll need to have a static method that replaces the constructor. So whenever client code needs to access the object, whatever it's storing, then it's going to have to go through that static method. Okay, so let's go ahead and see how that works. There's a couple different ways you can do it, and one is using statically allocated memory, and other is using dynamically allocated memory. I'll show you both. We'll go ahead and fire up Visual Studio, and I'll show you what that looks like, both versions. Okay, so the first version, we'll go ahead and create class Singleton, and with this class I'll use static memory allocation, and the key is going to be to create an instance of the Singleton that is static, and so it's going to be stored on the stack, and so we'll return a reference to that so that any client code that is going to try to interact with this object is going to go through that stack, okay, or to that location on the stack. Okay, so let's go ahead and see what that looks like. All right, so we'll have our private constructor. Okay, and you gotta have to have these curly braces here. Now this is going to guarantee that there's no way that you can just instantiate a Singleton in the normal way, right? So you can't say Singleton S, okay? That's not going to work because the constructor is private. But what we're also going to do is we're going to make a vector that is private. So this vector, or this Singleton class, this object is going to be responsible for maintaining this vector. And since we're making it so that a Singleton is managing that vector, there will only ever be one instance of this vector, and so anybody who wants to access it is going to have to go through the Singleton. So we're going to guarantee that there's only ever one vector. Okay. All right, so now let's do the static method. Okay, so static, and we will return a Singleton reference. Okay, we'll say get instance, and this will be where we create our static Singleton. Okay, we'll call it S, and then we'll return S. And the nice thing about this is that when the object is destroyed, it'll come off the stack, and then your memory will be taken care of for you. Okay, so now in main, what we'll do is we'll create a singleton reference variable. I'll call it S here, and then we'll access this static getInstance method. Okay, so singleton getInstance. Okay, so the first time we call that, this singleton object will be created, and that'll be the only ever instance that we get. That's gonna be it. All right, because the next time you call that method, remember how static variables work. You get one copy, and that's it, right? So this is gonna give us a reference to that singleton object that's living on the stack. Okay, now let's add a couple of methods for interacting with the vector, otherwise this isn't gonna be too useful. So we'll do, void add. Okay, and then we'll just do something like v.pushback I, and then we'll do a int get int I, and then what this will do is this will be an accessor, which will just return the element at the ith position. So return v of I, and then we'll do a size method. Okay, and then this will just return the size of the vector. Okay, so there will only ever be one instance. Okay, that's the idea here. So let's go and use this reference here to add some numbers. Add 7. Okay, all right, so that's 3 numbers here. So then we'll go ahead and we'll check the size of the vector, right? So with this invocation of getInstance, that's going to create that singleton object that's living on the stack. And since it's static, it's only ever going to be one instance of that single object. And so then we'll return that by reference. And so then that reference will be stored in this reference variable in main. And then we'll just go ahead and add some numbers to it. So it's going to go to this vector right here. And then we'll check the size of that vector. Okay, so let's see how that looks. Okay, so there is a size of 3. Okay, now let's create another singleton reference. And we'll call it T, and then we'll say singleton getInstance. Okay, now when I do t.size, okay, it's going to show me 3, just like it did for s.size, because it's returning a reference to the same static singleton object that's living in the stack. Okay, and since it's statically allocated, there's the 3 and the 3. Since it's statically allocated, as soon as the singleton objects go out of scope, then the memory is going to get cleaned up, no memory leak. Okay, now let's check the get just to prove to you that they're the same singleton object. See how s.get, and we'll look at the last element in the list. That should, or in the vector, that should be 7. Okay, and we'll do that over here as well. Okay. So we should see 7 both times, and we do. There's 7 for the first one, and then there for S, and then there's 7 for the second one. Okay, so basically here, both S and T are pointing at the exact same singleton object, which contains the exact same vector. There's one instance of singleton that was created. It's living on the stack because we used this static getInstance method, which created an instance of the singleton object on the stack, and we returned it by reference. Okay, so one more little quick example here. We'll say singleton U, and then we'll assign it S. Okay, so what that's going to do is, I should probably spell that correctly, singleton. what that's going to do is that's just going to take the memory address in that reference S and then assign it to U. So that way T, S, and U are all pointing to the same singleton object. So I'll do cout u.size. Okay. And there we go. Okay, so cout u.size, there's the 3. Okay. One more thing you can do here just to make sure you don't do an accidental copy, an element by element copy, is you can overload operator equals here const singleton. Okay, and that's normally returned by reference, and then just make that equal to delete. Okay, and so what that's going to do is that's going to make sure that the operator equals can never be invoked. So you can't do something like s equals t, okay, because that would normally invoke the assignment operator. Okay, and if you allowed that, then that would do a element by element copy or a member-wise copy, which would create 2 copies of 2 different vectors, 2 copies of this vector here, and then it would defeat the purpose of having a singleton. So you have the copy assignment operator, and you also have the move assignment operator. We can get rid of both of those. So that way we can't say something like, s equals t. See how the red squiggle shows up. And you could also get rid of the copy constructor. So singleton const singleton equals delete and singleton and the copy move constructor equals delete. Okay, so that guarantees that you can't do something like this. Singleton x5, or not 5, u. Okay, so again, guarantees that there's only ever going to be one instance of the singleton object that's created. Okay, and that therefore that'll guarantee that this vector resource will only ever have one instance. Okay, so that's what it looks like when you're using statically allocated memory. Now you can also do this. I'll just blank this all out, or I'll just comment it all out. So there you go. We'll just block comment that out, and then I'll show you what a singleton version looks like that uses dynamic memory allocation. Okay, so what we're going to do is we're going to create class singleton again. Right? And this time we're going to make a private static singleton pointer. And this is kind of how it would work in Java. We'll just call this s pointer, and then I'll create my vector like before. Okay, and then we'll create our constructor that's private as before. Okay, and then we'll put in our public methods here. We'll have our static variable, or a static method again, but this time it's going to return a pointer. Okay, and then we'll call this get instance, and this time this will check to see if s pointer is equal to null. If it is, then we'll dynamically allocate a new instance of the singleton. Okay, and then we're going to return the singleton. Okay, the pointer to the singleton object. So if it doesn't exist already, go ahead and create it and then return the result. Now here, what we're going to need to do is we're going to need to create that static variable. Because remember, static class variables are just kind of like a reference. They just kind of point to a static memory location. So that enables them to be shared across all instances of an object. But since we made the constructor private, there will only ever be one instance of this thing. Okay, but this is how we're gonna use the heap instead of the stack. In the previous example, we used the stack to store our singleton object, but since we're using dynamic memory allocation here, we're using the heap for it. Okay, so singleton, and then we're going to say s pointer equals null pointer. Okay, so that's going to create that static variable. Okay, or that variable that this is going to refer to. It's going to be initialized to null. Okay, so now whenever we want to access that vector, let's add some methods here for interacting with that vector. So we'll have void add, just like we did before, int I, v.pushback I. Okay, we'll have a get also, v.get. I could just return v of I. Okay, and we'll have size. Return v.size. All right, and this is an accessor too, so we'll make that const. Okay, so now in here we will go ahead and create a singleton pointer, and we'll call that I don't know, p. And then we'll assign to it get instance. Okay, now the first time we call this thing, it's going to check and see that s pointer is set to null. It'll create the new singleton on the heap and then return a pointer to it, which will then be stored here. Okay, and then we'll be able to do stuff like this: p.add 8, p add 6, p add 7, right? And then I'll be able to do cout p size to show you that the 3 values have in fact been added. Let's test it out. So there's the 3, just like before. Now I could create another singleton pointer and access that same singleton object. Now if I do cout p in q, you're going to see that I've got the memory addresses in both p and q that are the same, because there was only ever one instance of that singleton object that was returned, or that was created. So you can see 00001 EAF ECBD 7B0 and then D7P0, right? So they're both referring to the same object. Okay, so cout, we'll do q size, just to show you that they both are referring to the same thing, right? So they both have 3 elements in their vector, in the vector, right? Because they're both pointing to the same thing. Both p and q have the same memory address for the same singleton object. Now, just like with our statically allocated version that had that static local variable that was returned by reference, we're going to have to deactivate, or we're going to want to deactivate the copy constructors in the assignment operators. So let's do that. Const singleton, right? And we'll make that set to delete. And then singleton. We'll do the assign, or the copy assignment, and then the copy move. Okay, and then we'll do the assignment operator. Assignment copy and assignment move. The same reasons we did it before. That will prevent two different instances of the singleton object, and therefore two different vectors from being created. There will only ever be doesn't make any sense. It's not how singletons work. Now, there's one last thing. You probably might be looking at this going, oh my gosh, you have a memory leak in there. And you're kind of right. Okay, so normally you don't want, I mean, this is going to create a new instance that gets returned, right? Now, that singleton is sitting on the heap, and its memory address is now sitting in P, it's sitting in Q. So we could go in here and say delete P, and that would free up its memory, right? But normally you want objects to clean up after themselves. So what we could do is there's a lot of different ways we could do this. You could add a destructor to this thing. Another way you could do it would be to create a little subclass that just has a destructor that inherits the pointer, and then is able to delete it. So you could do something like foo inherits from singleton, right? And then just put a destructor in here. And we would need to be able to access that instance, right? So we could do something like, we can make this protected maybe. And then that would allow us to delete export. Then once we have that set up, then we could just create a foo. Right? And since it's going to be gaining access to the same pointer, it'll just delete it when it's done. In this video, so what do we talk about? Singleton design pattern and what its benefits are, two different implementations of it, and how you can clean up your memory. Okay. So as usual, if you're a student of mine, feel free to shoot me an email, stop on my office hours, hit me up on Zoom. If you thought the video was useful, please consider giving it a thumbs up. If you thought the video sucked, there's a thumbs down button for you as well. Please consider supporting the channel in different ways, as long as you're not a student of mine. We've got memberships for as little as 99 cents a month for additional perks. We've also got the super thanks button. Leave a comment, hit the subscribe button, hit the bell so you know when new videos are posted. Thanks for watching, and we'll see you next time.